Good afternoon, everybody. Welcome to our next session here. Flávio Juvenal is going to be speaking now on how to make a good library API. Let's give him a big hand.
Thank you, everyone. I'm really glad to be here with you today. It's an amazing opportunity. This is my first PyCon. And I'll talk about how to make a good library API. I'm not an API expert, but I studied a lot about this, saw what the giants are saying about this, so hope you enjoy. I work at Vinta, and I'm one of the partners. We are a small but expert Python, Django, React development team from Brazil. And we do custom web development for companies all over the world, mostly in the US. And here's a picture of our team, just to give you some context. And OK, just to make sure everyone here is on the same page, I'll be talking about general library APIs. So library model packages APIs, not just web APIs, even though the concepts that I'll discuss here can be adapted and applied to web APIs too. OK, so what you want to learn here is how to make a good API. And according to Wikipedia, and this is not like those crazy pages of Wikipedia, it's one that has good contributors, it says that a good API makes it easier to develop a solution by providing the building blocks to be put together by the programmer. And the programmer matters here, because it's for them that will make the API. We need to recognize that an API is a user interface. And we need to think about who will consume the API. We want to bring the human factor into the API design. By studying usability, we can summarize good UIs into 4 values: simplicity, flexibility, consistency, and safety. Those values usually overlap with each other, but we can use them to guide ourselves while building an API. In this talk, I'll get into details on simplicity and flexibility because of the limited time. But those 4 values are explored on this online checklist that we've built, and it's python.apichecklist.com. And you can go there and you find all these 4 UI values applied to Python APIs. This is an online checklist. You can check it, and it will save on local storage, so you can come back later. It's free, it's open source, MIT licensed, so feel free to contribute with it, create issues, disagree with something, just create the issue there, fork it, etc. I got those guidelines from dozens of sources, but I'm happy to have contributions on this. OK, now talking about the UI values applied to APIs. First, simplicity. The design of Python talks a lot about simplicity. And this is in the core design of Python. So this is something that we need to care about when writing our APIs. Beautiful is better than ugly, explicit is better than implicit, etc. This is all beautiful, this is all nice, but how we achieve that? The first idea for achieving simplicity in API design is to focus on the 90% use cases. And this means that 90% of our API users should be simply calling a function or using a class to fix their problem, to solve their problem, using our library API. But we will not forget the other 10%. We still need to handle those minor use cases, maybe by letting them calling multiple functions, changing attributes in classes. Then we also have to care about the 3%, which will call some functions intertwined with custom logic, or they will inherit classes to change methods. But of course, there will always be some developers, some problems that we won't be able to fix. And for this 1%, we can just ask them to fork and contribute with the API. And this means the 90% here is simplicity. and the other 10% is flexibility. So we will make the 90% possible through simplicity. The other with flexibility, which we'll talk about later. OK, but how can we discover the 90% use cases of our API? A good idea is to follow a top-down approach, so we can start with the README. We can write the README code even before the actual implementation code. And to do that, we should start pitching to our users. Our API is like a product to the users. It solves a problem for them. So we need to figure out why the library exists, what it solves, and to which extent. And you can see this on good Python APIs, like Pendulum, which exists for making Python datetimes easier, or Beautiful Soaps, which is a Python library for pulling data out of HTML and XML files. And we can show users how to use. We can write just simple code that doesn't even work yet, because we are not writing the implementation. But we should try to write this code to know how developers will use our API. Pendulum, for example, does that. Right in the first lines of the README, it contains sample code. And it's good to start like this, because you think more about the API design in a top-down approach. Other thing we must do is know our users. To do that, we need to get people involved in API design. We need to ask developers what they need. We need to share the problem we are trying to solve with developers. And we should ask them to use. You should ask your coworkers, ask random people on the internet, on chat rooms or forums or anything, to test your API. And then you figure out what will be the 90% use cases. And you also know the other 10% that maybe won't be so easy to do in your API, but with some extension, with some flexibility, we'll be able to do it. Other idea is to reduce clutter for these 90% use cases. This is also an idea for simplicity. To do that, we can follow a UI good practice called progressive disclosure. And what's that? Google homepage tells us a lot about progressive disclosure, because 90% of the users who go to Google just want to search something. Google.com, they probably want to search something. So Google is very focused on search on its homepage, and focusing on textual search. You can do image search, you can do other stuff, like visiting Gmail on Google homepage, but most of the users will be there to search, so Google's focus on that, making the more advanced options also available, but more hidden, less focused than the search. Here is an example of progressive disclosure in an API. You can figure out this on the Postgres search API on Django. You can just do a simple search by using the underline search, and you search for an egg. But you can do more advanced stuff. You can use a search vector that configs the description to French, and then you can search the query with French words. And this is the more advanced use case, but to do the simple use case, you don't need to use all the advanced stuff. You can just use the simple use case and you'll be fine. This is progressive disclosure. You are hiding the complex stuff without making it possible. It's also possible, but it's not just there for the simple users. And this means we need good defaults. This is what makes progressive disclosure possible. And to have good defaults, we need to make assumptions. We need to decide for the 90% of our users. We need to require from them only the essentials to solve their problem. All the other stuff, we can figure out for them. And there are many defaults we need to think about. Argument values, argument order, behavior, environment, many things we need to carry about to build a good API with progressive disclosure. Here is an example. The history API on JavaScript has a very bad default in push state, because most of the users, 90% of the users, will use push state just to add a URL to the history. But they can't just do that by just telling the URL to push state. They need to give a state object, then give a title that's not even used in modern browsers, and then finally just give the URL. Instead, the order should be the URL first, and the other stuff should have defaults. This would be a better API. Also, to reduce clutter, we should avoid cumbersome inputs. Sometimes the API misleads the client with cumbersome inputs. For example, the scrapI Melee API. It receives a 2-argument, and the 2-argument needs to be a list. So since it's not 2 lists or recipients list, many users just try to use this API, putting a single string. And then the scrapI would try to send an email to each character of the string, which users don't want. And they fixed that on scrapI 1.3 by also accepting the single string. They still accept the list, but they also accept the single string. And here's the issue related to this case. There's some discussion, it's interesting to see. And also, we need to check, related to cumbersome inputs, if the user is instantiating something just to call the API. For example, there was a change from Python 2 to Python 3, in fact, Python 3.2. The raw config parser only accepted a file-like object. It only accepted a file-like object with readfp. And if you had the contents of the config already loaded, you needed to use a string IO just to call the API. This is bad. The API should have a read string method to allow this use case, and this was fixed in Python 3.2. Another thing to reduce clutter is creating abstractions. And what's abstraction? We talk about that a lot, but we don't think much about it. And to abstract is to draw away from the physical nature of something. This is very poetic, very artistic. And with art, with abstract art, we will explain this. This is a painting with a low abstraction value. You can see that it's a tree. You can see the physical nature behind the painting. Then you can move to medium abstraction, and you can still see there is a tree, but it's more abstract tree. The structure suggests a tree, but it's less clear. It's getting farther from the physical reality. And we can do more. On high abstraction, there is structure, and maybe only structure. The physical nature disappeared. There's no tree there. Only the nature of hierarchy that tree suggests. And through abstraction, we highlighted the concept of hierarchy, and we got rid of the concept of tree, which is the physical nature here. And those paintings are from Mondrian. Eventually, he got into total abstraction, and he's probably more smart than all of us because he can see things like this. And to abstract in APIs means that we need to draw away from the how nature of things to focus on the what nature. This is the concept related to APIs and abstractions. In practice, here's an example, Celery. Celery is a great API because it solves the problems of background tasks, and the implementation involves task queues, workers, message brokers, serialization, lots of stuff that we don't need to care much about when you are writing your own tasks. You can just say app.task, and it is solved. Celery is abstracting out the implementation. It's not focusing on how. It's focusing on what. What do you want? You want a task? OK, just use this declaration, and you have it. Beautiful Soap is also a great API. It supports selecting HTML DOM elements with CSS, and you can just use HTML Soap, select, and you are done. You just need to say what you want. You don't need to say how you want. Pillow is also maybe not a great API, but a good one, because it allows you to rotate images and do some stuff with images without caring about linear algebra. You just do a rotate, and it's done. What is what matters here? What do you want? You want to rotate. OK, how do you do it? Pillow will do it for you. And here we learn that abstractions enable brevity. Good abstractions reduce the clutter. Good abstractions reduce the verbosity. OK, but not everything is beautiful about abstractions. There's a thing called the law of leaky abstractions, and it says all abstractions leak. Back to salary, unfortunately, I lied when I told you that you don't need to care about workers and everything, because workers can crash. This happened at Vinta. We made a deploy that stopped at salary just when a task was running, and we got this crash error. And because this exceptional condition broke the worker, we need to care about the implementation, because the implementation needs to run the task again. So our tasks needs to act late. That means that they need to tell that they worked properly after they are done, but we also need idempotent tasks, so the worker can run the task again without causing side effects. And because of this, because of the nature of the worker, the abstraction leaked. We needed to care about how it works on the implementation side. We are not just on the what side now. And it's impossible to abstract perfectly, because all the abstractions are lying. They are hiding the physical nature. And sometimes these leaks are even necessary. Complex is better than complicated. Let's remember that from the Zen of Python. And it's better to embrace complexity than creating complicated situations. Classical example is RPC. RPC abstracts a lot, but it creates complicated situations. You can, for example, get a Facebook profile and set the name, but if another user does something while you getting the profile, setting the name, you have a conflict. Because here you are pretending that servers and clients, that distributed systems work just like a local system, but they don't. Distributed systems create conflicts. And it's better than using this kind of API, using a more RESTful API, an API that embraces the complexity between the client and the server. And REST does that, and it supports this with if unmodified scenes. And now you can have an operation that prevents conflicts, because it won't modify something if it was already modified. So RPC is like trying to explaining relativity or quantum mechanics for an 8-year-old kid. You just can't do that. You can't simplify this stuff, because it's so far away from the regular physical reality that you can't simplify it. Sometimes it's better to embrace the complexity. Still in simplicity, the third and last idea to make it real is to make it Pythonic. And being Pythonic has everything to do with the principle of recognition rather than recall, because Pythonic APIs look like each other. You wouldn't want in a user interface that Control-C meant something else than copy. And the same way, you have to follow Python patterns, Python idioms, when building your APIs. You need to do what is natural to do in Python. For example, there's a change that happened in config parser from Python 2 to 3, which is get an option value from the named section. That's the use case. And in Python 2, you needed to do that with parser.get, and you pass the section, then you pass the option, the key that you want. But this API is not natural to Python, because dicts don't work like that. On dicts, the second value of get is the default value, and the first one is the key. So a user might think that parser.get works like a dict, but it doesn't. And in Python 3.2, this was solved by having a dict-like interface on the config parser. OK, enough of simplicity. Let's talk now about flexibility. We talked about what makes the 9% simple, but what makes the 10% possible? One of the main problems we face in API flexibility is the integration discontinuity. And to explain integration discontinuity, we must think about options of integration. When you are looking for a library to solve a problem, you have multiple options of integrating it in your program. You are on a solved state, and now you have three options to solve the problem you have. You can just use the exact solution you need, then you move to the solved state. You can use a more complicated solution that will be slightly overkill in that same library. And you can use like a low-level API from this same library that would be way overkill. And you probably shouldn't try this. And this is actually good, because what is solved for you might be overkill from other user. What is overkill for other user might be exactly what you need to solve the problem. So to have multiple options of integration is actually good. And discontinuity is when you don't have these multiple options of integration, when you just have an unsolved state, and then if you use the library, you are on a way overkill state. And to prevent that, we need to increase the granularity of the API. And to increase the granularity, we need to separate the concerns. For example, you can have a print formatted function that prints hello world into red and bold. OK, then an API user comes and say, hey, my out is not the standard output. I want to out this to some other output. And then you think, OK, then I will add a parameter out for that. But that's not the best solution, because print formatted is not a single concern. It's two concerns inside a single function. So the best option would be to break print formatted into print and formatted functions. Now you have a more flexible and more granular API. Another thing that helps granularity is the multiple levels of abstractions. As we've seen, Celery supports a high-level abstraction for tasks. But it also includes a low-level API that you can inherit from task, and you can do more config on it. This means that it's flexible. 90% of the users can just use the decorator, but the other 10% can use custom classes for tasks and everything. Other idea is to increase the opportunities for extension. There is one thing that's called the mock patch smell, that every mock patch is a missed option of integration. That's a bold statement, OK, but let's see why. Look for mock patch in your tests. What they do, they are basically a monkey patch, but in tests. So here you have a scheduler that has some delay and will execute a task after this delay. And to test this, you need to mock the sleep, because you don't want to wait 10 seconds just to test this. So you have to mock the time sleep with custom sleep. But if you are mocking on your tests, maybe your clients will need to monkey patch when they are using the API. And scheduler from Python recognizes that and supports time func and delay func. So you can just pass a custom sleep to scheduler, and then it will work with this. It's like dependency injections with just high-order functions. And this is good. This is fine, because you are preventing users to monkey patch if they want some custom behavior. There's other smell. That's the attribute versus method smell. And we can see an example of that in that change that happened in Django REST framework. On cursor pagination, users were requiring that page size could vary according to the request. But this was impossible, because the page size was a fixed attribute from the cursor pagination. And this was fixed by introducing a method, a new method, which is getPageSize. And here's the issue related to this. So we need to take care about if we should have an attribute or maybe a method that generates that attribute. This will allow more flexibility, more options of integration. And finally, we need to be Pythonic. And one thing that's very controversial, but I think it's a good way to think, that design patterns are a missing language features. If you are having to do design patterns, it's maybe because your library, your language, doesn't support many features that it should have. For example, adapter pattern, no, in Python, don't do that. Just use duck typing. With duck typing and easier to ask for forgiveness the permission, we can avoid building adapters. You can just call, and if it gets an error, you can catch that error and raise a type error, OK. But you should just call. You should accept the objects that the client passes to you. An exception from that is abstract basic classes, which you can see more on this PAP. And here's an example. The Django avatar supports custom providers. And the provider is really an adapter. It adapts the Facebook API, in this case, to the get avatar URL. That's the API that Django avatar supports. And Django avatar doesn't care about the type of your provider. It just calls it and passes the user and the size. And you can just define any class you want to adapt this behavior to the API you are using. And this is good. This means that it's respecting the typing and it's flexible. And other thing is the strategy pattern. Forget it. Just use high-order functions. For example, in Python, the list sort accepts a key that gives the strategy to sort the list. But in Java, for example, you have to inherit from comparator to create an adapter and everything, to create a strategy and everything. And this is not necessary in Python. You just use a high-order function. And there's many more things to do to be Pythonic. You need to use properties, magic methods, decorators, iterations, and everything. All of these increases flexibility. All of this is good. These are features from Python that make your API more flexible. And to conclude, if you want to get one thing from this talk, this is it, that you should make an API that makes the simple easy, the complex possible, and the wrong impossible. So this means that simplicity is the simple easy, flexibility is the complex possible, and consistency and safety, which I didn't talk here, is the wrong impossible. And this is basically what we need to have in mind when building our APIs. So that's it. Thank you very much. Feel free to reach me.
Thank you. Thank you, Flavio. We have time for a question or two, if anybody wants to step up to the mic. All right, well, let's have another round of applause here for our speaker.
Thank you. Just a word. Sorry. In the same room, there will be another talk about APIs, so you might be interested too. Thank you.
Good afternoon, everybody. Welcome to our next session here. Flávio Juvenal is going to be speaking now on how to make a good library API. Let's give him a big hand.
Thank you, everyone. I'm really glad to be here with you today. It's an amazing opportunity. This is my first PyCon. And I'll talk about how to make a good library API. I'm not an API expert, but I studied a lot about this, saw what the giants are saying about this, so hope you enjoy. I work at Vinta, and I'm one of the partners. We are a small but expert Python, Django, React development team from Brazil. And we do custom web development for companies all over the world, mostly in the US. And here's a picture of our team, just to give you some context. And OK, just to make sure everyone here is on the same page, I'll be talking about general library APIs. So library model packages APIs, not just web APIs, even though the concepts that I'll discuss here can be adapted and applied to web APIs too. OK, so what you want to learn here is how to make a good API. And according to Wikipedia, and this is not like those crazy pages of Wikipedia, it's one that has good contributors, it says that a good API makes it easier to develop a solution by providing the building blocks to be put together by the program to guide ourselves while building API. In this talk, I'll get into details on simplicity and flexibility because of the limited time. But those 4 values are explored on this online checklist that we've built, and it's python.apicchecklist.com. And you can go there and you find all these 4 UI values applied to Python APIs. This is an online checklist. You can check it, and it will save on local storage, so you can come back later. It's free, it's open source, and the programmer matters here because it's for them that will make the API. We need to recognize that an API is a user interface, and we need to think about who will consume the API. We want to bring the human factor into the API design. By studying usability, we can summarize good UIs into 4 values: simplicity, flexibility, consistency, and safety. Those values usually overlap with each other, but we can use them